So in this tutorial of part 2 of the visualizer, we're going to go through how you annotate chemicals of interest, and especially PFAS chemical series, using a 6-step process. Now, using the visualizer, you can do a lot more than just this. This is just the workflow that I've come up with to validate PFAS and discover new PFAS. So I'm excited to see the workflow that you come up with. So in this part 1, we'll just go over the first two. So going through confidence series that have a score of A and those that have B and B+. A is going to be those that are rule-based annotation based on standards, and so they're very confident, and we have about a 5% false positive rate. B and B+ are going to be those that are also based on MSMS, potentially rule-based from standards, but are less confident. They may not have all the required fragments, or they might be from in silico spectra. So, going into our data, we can filter using the score functionality. So if I select A, I will see all those features that were annotated with very high confidence. So we see 1, 2, 3, 4, 5, 6, 7, 8. Note here that we're by default filtered to negative 0.05 and positive 0.05 mass defect. If you want to look at everything, you might change this to negative 1 and positive 1, or negative 0.5 and positive 0.5. Note that, as you can see here, there's no more confident identifications, and the reason we have this filter is that generally all PFAS fall within negative 0.05 and positive 0.05 mass defect. Now let's look at a series of interest. So here's perfluorocarboxylic acids, and you can see the second to last row is series 114. So we can go to this filter over here, type in 114, and select it. Now we only see members of 114, and we can change the score to show all those members. So now we're not filtered by score, and we're seeing all of those that are 114 belonging to PFCA. So this Kendrick mass defect plot is very helpful for pulling out series. You can see that for any series, they form a straight line horizontally because they have the same mass defect. Mass defect in this case is normalized to CF2, and so that all chemicals that only differ in CF2 chain length, as you can see here, this has a chain length of 6, then 7, then 8, but they all have a carboxylic acid, so they only differ by chain length, form a straight line, and they should also be 50 Daltons apart in the case of CF2, or whatever the repeating unit may be. So this is a great visual to pull out and look for series, whereas this visual over here is great for validating series. So all these orange dots have different levels of MSMS annotation, etc. Some have no MSMS annotation. But you can see that they form this very nice trend line. And so this trend line can be used to validate that all of these probably belong to the PFCA series, and I'd be okay with including these. Whereas these two features over here probably do not belong to the PFCA series, and I would consider those false positives. Now, the way that you would enter your findings into your data depends on you, but generally I like to open up Excel into a separate screen. I'll keep it in the same screen for now. And we want to look for this series, 114. So 114 happens to be our first series here. We do Control F at what it wasn't. Here you can see our two members that has scores of A. And we can look at which ones are false positives and validate the rest. So it's going to be feature 38749 and 22811. So here is 22811 and 38749. And so these are the two that are false positives. You note that they don't even have a formula, so they didn't match exactly with the accurate mass anyway. Now, going into these, we can scroll to the right. And you can see in the new software, there'll be columns already set for you to add your comments and notes. But in this case, I'll just add my own where it says, okay, these are false false, and the remaining are going to be true for this PFCA series. To help yourself out, you can freeze panes over here if you're using Excel. So let's just look at like this. All right, and so here they are, and we know that the rest are true. So that's one way that you could potentially do it. You can also, if you want, start giving them specific names. So I know that this is going to be PFCA, and I know that it's going to be AC3. And so then I can do this so on and so forth. So C4, and then C6, so on and so forth. This is C7, this is C8, this is C9, C10, C11, and C12. So we have all these members. Now we can go back to our visualizer, and we would then go through all other members of A. So first we're going to unselect 114. We can select A again, and for example, now we could go to the second most common PFAS, PFSAs. Maybe we wanted to go to sulfonamides, some fluorotelmer, sulfonic acid, so on and so forth, and repeat this process until you have all of these accurately annotated chemical species. And then you can do the same thing looking at Bs. Generally, Bs and B pluses are much more accurate than B minuses, which don't form series, and B minus, which might not have fluorine or common fluorine related fragments. So here's some Bs. We can see some things that already have series. So this is a fluorotelmer carboxylic acid, and we can do the same process here. For these, you might want to look at the spectra and make sure that you have the right annotation, given that these are lower confidence hits that you can't just believe by looking at our annotation. So here you can see that it has a very large fragment in the full scan. And here are the different isotopic peaks, so you can look and make sure the isotopic ratio makes sense compared to theoretical. You can also see some of the fragments over here. So not necessarily extremely common fragments. Here's a carboxylic acid related fragment though for this one, and we can look at this one as well. See again some of these fragments, similar pattern. So it does look like it is a carboxylic acid containing PFAS, so it may be correct. Here's one last one. It's interesting to note that if we look at, for example, sulfonic acid related chemicals such as this one, we should be able to see, let's look at scores at A as well. Here's our PFCA C6, so one of the more common ones, and this is going to be our PFC C8. And you should often be able to see 2 units away the sulfur isotope peak. So this will help validate if you have sulfurs or other chlorines or other ions that form very clear isotopes. You can also confirm the structures for Bs in this way. So you have to figure out what your confirmation schema is for Bs, and then just like A's, you can pull them together and get all of those members in series confidently annotated. All right, so that's it for part 2. In part 3, we're going to go over discovering new PFAS or series that potentially don't have any annotations.